Okay. So here is practice problem. So we have to, since it's a rational equation, we found the LCD and multiplied by the LCD. Most of you did find the two answers when you did your algebra. We should have got x equals 2 and x equals 4. I'm gonna go through that process in just a second for those of you who didn't get that. There was a couple of you that didn't get that. But one thing that we really haven't had to see before is we always want to check for extraneous. This one doesn't actually work because if I try to plug it in for x, it will give me a 0 in the denominator, which is undefined. So we're going to talk about that a little bit more after we solve this. So if you got those answers, that means you did all your algebra correct. I'm just going to go through the process of where those are coming from in case you didn't get those. So the first thing we want to do, if we want to find the LCD, is I need to factor any denominators that are not factored. This is the only denominator that can factor more. So I'm going to rewrite this. The numerator stays the same, x minus 4, but I'm going to factor this trinomial into two binomials using the shortcut. I'm looking for the numbers that multiply to be 6 and add up to -5, which would be a -2 and a -3. That would multiply to be +6 and add up to -5. So those are my factors, x minus 2, x minus 3. These other two fractions don't factor. When I have something like x minus 2, they're not multiplied, so I just keep it as one single factor. I'm just going to write it in parentheses. So x over x minus 2 minus 2 over x minus 3. Okay, so now that it's factored, now that the denominators are factored, I can find the LCD pretty easily. I look for common factors. Those ones have an x minus 2 in common, so I have to include the x minus 2. And then these two fractions have an x minus 3 in common, so I have to include the x minus 3. And that uses all the factors. Okay, so that's my LCD. Once I know my LCD, I multiply everything by the LCD. So I'm multiplying everything by x minus 2, x minus 3. The reason we do that is to get the fractions to divide out. So on this fraction, the x minus 2's divide out, and I'm left with x and x minus 3. Okay. Then we have our minus sign right here, so we always have to be careful of the sign. From this fraction, the x minus 3 divides out, and I'm left with the 2 and the x minus 2. And then on this side of the equal sign, both factors divide out. So I'm just left with x minus 4. Okay. So I got rid of the fractions. Now I want to simplify each side separately. If I need to simplify this side here, I'm going to distribute and combine like terms on the left. So here, if I distribute, x times x would be x squared. X times -3 would be -3x. Here we also have to be careful of the sign. This will give us a -2x and a +4 because I have a -2 times a -2. Then I can combine these since they're on the same side of the equal sign. So on the left side of the equal sign, after I distribute and simplify, we should have x squared minus 5x plus 4. On the right side, we have x minus 4. Okay. So after we do that, hopefully you all notice that this is a quadratic equation. Remember, quadratic means it has an x squared. So to solve a quadratic equation, I want to get one side equal to 0, and then I can factor. Okay, so I'm going to get this side equal to 0 here. To do that, I have to get rid of the x, so subtract x. And I have to get rid of the -4, so I'm going to add 4. Okay, that's going to give me a 0 on right. Then on this side, we would have x squared minus 6x plus 8. Okay. Now, once this is equal to 0, you can solve this with either factoring or quadratic formula. I will factor using the shortcut. So I'm looking for numbers that multiply to be positive 8 and add up to negative 6. Most of you found those two numbers. What were those two numbers we could use? 2 and 4, and they would both have to be negative, negative 2 and negative 4. So these are my factors, x minus 2 and x minus 4 equals 0. Then I solve, I set each factor equal to 0 and solve each equation. So x minus 2 equals 0, I add 2 to solve, and I get x equals 2. On this one, I add 4, both sides, and we get x equals 4. Okay. So the algebra on that looked really good. So like I said, if you got those two answers, you did all your algebra correctly. Here's the one part that we have to remember to do. And I don't think anyone remembered. We always want to check for extraneous solutions. Okay, so on a rational equation, what that means is I can't get a 0 in any denominator. So when we check, that means we want to plug in our solutions and make sure they work. Notice what happens if I plug in a 2 into this denominator here. I'd have 2 over 2 minus 2. That would give me 2 over 0. Can I divide by 0? No, it's undefined. If you try to do it on a calculator, it'll tell you you have an error. So what that means is this doesn't work. It means it's extraneous. So then, if I plug in the 4 to the denominators, here 4 minus 2 or 4 minus 3 would not give me a 0. So this one is a valid solution. So my only solution, there's only one solution here, is x equals 4. Okay. So overall, this actually looked really good. This is the type of problem we solved on Thursday and Friday. We're going to do a couple practice problems with the next type of problem. All right, here's our next type of problem. This type of problem, these are the ones you saw on the video from Monday. This is a radical equation. So just to refresh your memory on a radical equation, the first thing you want to do is isolate the radical. So get the square root part by itself. Then this one happens to be a square root. So how am I going to get rid of a square root? Square both sides. I'm going to raise both sides to a power of 2 in this case. And then we can solve and check. Always check for extraneous. Okay, so I'm going to give you a couple minutes to try this one, and we'll go over it in a couple minutes if we need to. You need to get rid of the negative 3 first before you square both sides. And since this is negative 3 multiplied by that square root, to get rid of it, we can divide both sides by negative 3. So do that first, and then you can square both sides. What was on it? You don't know. So if you're going to divide everything, you're going to find a way to do what you do. So it's actually going to be easier to subtract the 2 first and then divide it. Yes, because this, when it's the -3 is just in front of the radical, multiply by the radical. So to get rid of it, we have to divide. So far, yes. Yeah, so I was kind of one, so your algebra is correct. Don't forget to check for plug the 26 into the original equation. So your algebra is correct. You want this to check, you want to plug this in the original equation, see if that's yeah, so all three of you, your algebra is correct. We always want to be in the habit of checking for extraneous solutions. So to check, we want to take our solution and plug it into the original equation to make sure that it works. So plug the 26 in for x. So what that means is this is extraneous or it doesn't work. It this will be correct, but before you divide, you actually want to get rid of the 22. You want to subtract 2 first. So then, yeah, and then divide by the yeah. And now, so now this is by itself. Now you can square it to get rid of and equals 17. So then you want to simplify this side to see if it equals 17, to see if the two sides end up being. So 26 minus 1 is 25. That's on the outside of the radical. Yeah, and then you can simplify. Yeah, and this is actually a -3 on the outside. Yeah, so then it'd be -3 times 5 plus 2. Yeah, -15 plus 2. We'll go over the checking part. So this side, when you simplify all this, -13, and this side is 17. Is that a true equation? Yeah. That means it does. So no, it's already a square root. So to get rid of a square root, square both sides. If I square this side, I have to square this side. On this side, the square root and square get rid of each other. This side, I actually want to find that number, -5 squared. That's -5 times -5. Yeah, and then all right.
Cuando no tiene número ahí. Cuando no tiene número ahí, es por.
So I think every person did algebra. And you should have got x equals 26. However, when we check it, we're going to go over the checking part together for sure, because it doesn't make the equation true. It doesn't work. So it's an extraneous solution. That means there's actually no solution for this equation. Okay, so I want to go over the checking part to make sure we see how we do that. I'm just going to go through the solving real quick. We do want to isolate the radical first, so I have to get this by itself. I would subtract the 2 to get rid of this plus 2, but I still have that negative 3 in the front. This is negative 3 multiplied by the square root. So to get rid of something that's multiplied, I would have to divide. So to get rid of that negative 3, I divide both sides by negative 3. And then I have square root of x minus 1 equals negative 5. So that was step 1, isolate the radical. Step 2, we raise both sides to a power. Since this is a square root, I would have to raise it to the second power. So I have to do both sides to the second power. So on the left side, the square root and square get rid of each other, and we have x minus 1. On the right side, negative 5 squared. Remember, that means negative 5 times negative 5, which is positive 25. And then we solve for x by adding 1. So that's where we get the x equals 26. Okay, but this is the part we have to remember. We want to check our answer. So what it means to check our answer is we want to plug this in to the original equation here and make sure it makes the equation true. Okay, so I'm going to show my work for checking over here. So when I plug it in, when I plug 26 into the original equation, it looks like this. Negative 3 times square root of 26 minus 1 plus 2 equals 17. I would simplify the left side here. Square root of 26 minus 1 would be square root of 25. So we have negative 3 times square root of 25 plus 2. Square root of 25 is 5. So this would be negative 3 times 5 plus 2. Negative 15 plus 2 would give us negative 13 on the left. And we have 17 on the right. Is that true? Is negative 13 equal to 17? No, not true, which means this doesn't work. It is extraneous. So when that happens and there's no other solution, that means if 26 isn't a solution, there is no solution. So on this one, the algebra actually looked great. Everyone got the 26, but we want to remember to check. One other thing I want to point out, you don't want to do all this algebra. You can always plug this here into the calculator. You could plug the left side of the equal sign into the calculator. I'm going to show you what that would look like. So on my calculator, if I wanted to check using the calculator, I would just type it in, negative 3 square root. I'm plugging in 26 for x, so 26 minus 1. And then the plus 2 is outside the radical. I have to use the side arrow to go outside the radical. And then plus 2. And that will give me a negative 13. If you don't feel like doing the algebra yourself, you can do it on your calculator. And you'd have negative 13 equals 17, which you can see doesn't work. We're going to do one more problem. This one is also another radical equation. So same thing, I want to isolate the radical first. Then I need to raise both sides to a power. That's where this one's a little bit different. Since this one's a cube root, what power do I have to use to get rid of a cube root? I have to cube it. I have to do it to the third power. And then we can solve and check. All right, so go ahead and take a minute and try this one. And we'll check over it in a couple minutes.
Yeah. So now you can plug that in for X. Just check your sign here. This, I think you just don't hit inside the parentheses, or maybe you forgot to write it. 3 minus 7 would be -4. So if I have -4 cubed, that means -4 times -4 times -4 would be -60. So just be careful of your sign there. Yeah, yours is good. Oh, okay, I see your mistake. So here, this is right. So then on this side, because you cubed it, the cube root and cube get rid of each other. So now what's left on this side now? Yeah, just the 2 minus 7. And then this one, be careful of your signs because this should have been 3 minus 7, should have been -4. And so then -4 cubed would be -4 times -4 times -4, which is equal to negative. So then I think you squared it again, or I don't know. Now you just solve the x by itself. It's -64. Because this, that means -4 times -4 times -4.
It was just 2 of them, it'll cancel off. If there's that exponential.
Yeah, so this would be positive 60, and then times another -4. So you just yes, you would just do, because it's multiplied by 2, you would just put -57 over 2, like in the parentheses. Oh, yeah, I'll show you guys how to do the cube root in, this is not here on our screen, so to get to it, you're gonna go math. And then it's that fourth one down. Yeah, that's correct. And you can leave it as a fraction or you can put it as a decimal. Perfect silence. Negative 64.7 would be negative. Which is negative. Yeah, so then, and also when you're plugging the calculator, this 7 is outside the radical. Yeah. No, you're right. Yeah. So now that's the exercise. So that's just even as a fraction, or you can put it as a decimal. So then this would be negative 4 plus 3, or negative 4 plus 7. So you get 3 plus 3, which is true. That means it does. It is, yeah. So it's not here on our calculator. Find it, you go to math right here. And it's the fourth one down. Yeah. Oh, hold on. Oh, hit enter. Yeah. Then you can type it in. Okay. Good, everybody. Yeah. All right. I think that we all got our solution. But I do want to show you how you can check this on the calculator because we have a cube root on this one. So our solution should be negative 57 over 2. Some of you left it as fractions and some of you put it as negative 28.5. Either way is fine. So where that comes from, first, step 1, isolate the radical. So I have to get rid of this plus 7 that's outside the radical by subtracting 7. So then I have cube root of 2x minus 7 equals negative 4. Okay. Then to get rid of a cube root, I have to raise it to the third power. So I have to raise both sides to the third power. So on the left side, the cube root and cube get rid of each other, and we just have 2x minus 7. On the right side, this is the only place I saw some errors on the signs. Negative 4 cubed means negative 4 times negative 4 times negative 4, which is negative 64. And then we just solve for x for there since it's a linear equation. So add 7. So 2x equals negative 57, and then divide by 2. So the solving part looked excellent. Now I want to show you what this looks like when we check our answer. And I want to show you how to check it on the calculator, because obviously that saves us time. So when I'm checking, I'm plugging this in for x right here. In the original, you always want to plug it into the original equation. So here's what it looks like. Cube root of 2 times negative 57 over 2 minus 7, that's under the radical. And then the plus 7 is outside the radical, equals 3. So I plugged the x in here. I can save myself time by doing this side on the calculator. That means we have to know how to enter this cube root on the calculator though. So if we look at our calculator, it's not on any of our buttons here on our home screen. We have to go to this math menu here. So you can hit math. And then it's the fourth one down, the cube root right here. So I'm going to show you what it looks like if we type that in the calculator. Okay. So I put it on cube root and hit enter. And then under the cube root, I had 2 multiplied by negative 57 divided by 2. I'm just going to put that in parentheses. And then let me just check.
The -7 was under the radical. Then we had a +7 outside the radical. So to get to the outside of the radical, you have to use the side arrow button. Now my cursor's outside the radical, so now I can hit +7. Once we simplify that on our calculator, it just gives us 3. That means this side of the equal sign simplified to 3, and the other side was already equal to 3. So this is what we get, 3 equals 3. What does that mean if I get an equation that's true? It is a solution. So this does work. X equals -57/2 is our solution. All right. So that's where we're going to stop today. Tomorrow we'll do one more type of radical equation. You did see one like this in the video, but we haven't had a chance to practice it yet. Notice on this one, there's an X under the radical, and then there's also an X on the outside of the radical. That just means more algebra for us. All right, so we'll do one like this tomorrow and hopefully continue some of our notes tomorrow as well.